Do you hear me? Do you hear me? Check, check, check. Oh, do you hear me? Thanks. All right. Uh, so it seems you won't be able to come to university. So therefore, during the next seminar, you can write your online test. Last lecture yesterday, we collected some questions for the exam. So please, till the next lecture, just look at it. If you feel uncomfortable with any of the questions, we can go through it again. I picked up 4 topics we should repeat or at least go through it. That's the topic of the lecture. So the seminar, we will finish it with the seesaw example. That's very, very easy. And the pure rolling example, which is pretty similar to the box on the incline example, except it can also rotate. Let's solve it again. So we have a seesaw. Sorry, my smart board doesn't work, so I have to draw in paint. Let's put one box here and another box, for example, here. And if the R1, for example, given meter, you should calculate what is the R2. Let's say M1 equal 2 kilogram, M2 equal 3 kilogram, and R1 is 1.5 meter. Perhaps you have formula in your pocket that can solve easily, but I also can ask what is the torque U1. You remember we have a weight here, we have another weight here, and the torque U is R1 cross G1. These are vectors, so I only can answer what is the direction of this torque U. You should say that, see this right hand rule, if the R1 is this finger, is the G1 is this finger, the direction of the cross product will come out of your screen, so towards to your face. Of course, the condition for equilibrium for rotation means all the torque added by vectorial has to be 0, because the net torque is the moment of inertia times alpha, and equilibrium means alpha is 0. So for any body, any shape and any mass, the seesaw will be in equilibrium if the sum of the torque equals 0. Can you answer the question, what is R2? And also I want to see what is tau 1. Only the magnitude. And what is tau 2? Only the magnitude. I will give you, let's see, 3 minutes. Alright, let's talk about tau 1 and tau 2. Just look at this formula. This cross product can be seen like this is the axis of the rotation, which is the origin. And what is the level arm for this G1? The level arm, this is a constant. The level arm in this case, since this angle is 90, the level arm is the length of the R1. So this is a vector. This vector come out of your screen and point towards the U. Its length, the length of the torque, is the length of the radius, the length of the force, and the sinus, this, let's say, theta, but this theta in this case is 90, so sinus 90 is 1. So the magnitude, the length of the tau vector is the length of the position and the length of the force, which is, the force is 20 Newton, the G1, and of course this G2 is 30 Newton. 1 meter, or 1.5 meter times 20 Newton is 30 Newton meter. So instead of this cross product, you can, if it's 90 degree, you can only multiply the length of the R and the length of the weight. Is it clear now? And the direction is point to U. Let's say this is point to U. This is the tau 1 as vector, and this is point backwards, but has to be the same. Is it clear now? And since the sum of these are 0, because this is 30 Newton meter, if you place your phone on your table upwards, if it's 30 Newton meter downwards, the sum of it will be 0. Therefore, the seesaw is in equilibrium. It's balanced. Were you able to calculate the torque 1, torque 2 also? All right. Let's go through the other example you will see in the test 2. This is the pure rolling. This is a cylinder. We move it through a force, with a force through an axis of the rotation. So we have a table or surface, and this is a cylinder. has a mass, axis of the rotation, and the radius. It's a surface with friction, and we move it with a force F. Let's say F is 100 Newton, radius is 0.5 meter, mass is 10 kilogram. The mu is large enough for pure rolling, but you will check at the very beginning, so let's say 0.8. So this is the example, these are the data. What can we use to solve it? We know if there is friction, if there is mu, the friction has to be something, let's call it T. It's an unknown, and also we should find what is the acceleration, angular acceleration, and what is the T. But fortunately we will have 3 equations and 3 unknowns, so we can solve it. What can help us to solve it? At first, for translation, we know sum of the forces will be m times a. So if this is the x-axis, we have to worry only about the x components of the forces and x components of the acceleration. Let's choose if this is a positive direction to your right. So the sum of the forces means this F force minus T, that will equal to m times ax. What about, so this is the dynamical equation, F equal m times a for translation. What about rotation? For rotation, we know that the sum of the torque will rotate the body via moments of inertia. But if this is a cylinder, this moment of inertia means 1 over 2 mr square. What is the torques? Fortunately, this F goes through the axis of the rotation. It means if the fork goes through this axis of the rotation, the level arm is 0, since the level arm, by definition, the distance between the line of action, technically the vector of the force, and the origin. If it goes through the origin, it has to be 0. So the only force can rotate this body is the T. What is the level arm for the T? So what is the distance between T and the origin? This is fortunately R. So the rotation T times R equal 1 over 2 mr square times alpha. So this is translation, this is rotation, and like the incline example, we have to assume something. Let's assume this is a pure rolling. Pure rolling means the acceleration and the angular acceleration are not independent, neither the velocity and the angular velocity. These are connected, values connected by the r. Here we have 3 equations and 3 unknown. Let's solve it. At first, let's divide it. T times r equal 1 over 2m. Let's divide the r squared to r times alpha, and see this can be replaced by a. There are r on the both sides. So if we simplify this equation, this is 1 over 2 ma. Let's go with this result, which is a merged result of these two here. F minus 1 over 2 m a equal m a. And by definition, since this is the x direction motion, ax and a is the same. F equal 3 over 2 m a. And here we have only one unknown, since f is 100. This is 3 over 2 times 10 times a. This is 30 over 2, 1 half, 15, 100 over 15. A will be, A will be 6.6 meter per s square. Since we know it, next step, go back with this A here. 6.6 equal 0.5 times alpha. So we have to only multiply it by 2. So alpha equal 13.3. This is 1 over s square. And next step is go with the a here. T equal 1 over 2 times 10 times 6.6 equal 33.3 Newton. But we had an assumption at the beginning that this is a pure rotation. These equations is true only for pure rotation. What is pure rotation? Pure rotation means that this force is a static force, means have to be smaller equal than the perpendicular force, which is the weight in this case. This is 0.8 times 100, which is 80. This is an assumption. How can we check this assumption? If this is true, that the T is smaller or equal than mu times perpendicular force, let's check it. Is the 33.3 smaller or equal than 80? The answer is yes. So that means this is a pure rolling. All these equations are valid. I won't give you any example where it's not valid, but please check it at the end. And that's all. So you solved how this cylinder translates and rotates on this surface with this mass, with this radius, and with this force. So the answer will be 6.6, 13.3, and 33. Were you able to solve it? And once again, I won't give you any example where the mu equals 0.1 or something and it's not a pure rolling. It's you don't have to check it. All right. All right. Um, if you feel you can't solve it, we can talk about not having this example or the seesaw. I mean, I don't want to stress you at the very end of the the semester. Do you want? I mean, of course, it's too easy the seesaw example, but that's it. You are not physicists. You don't have to deal with this equation. It's just a nice example. What is the complexity of the physics? Lots of equation, check condition, and so on. So, do you want to have only the seesaw example in the test? If yes, say yes. Or if you feel challenging this example, we can go through it again and again. We also have lecture next week before the test. So what is the answer? Only seesaw example in the test? But that will be the shortest test of your life because that's really 5 minutes. I I don't mind that. So the aim of this physics is to show you what is physics. You've seen what is physics, even if you don't want to solve it. I see. Oh, sorry. Oh, I was sure that. Oh, sorry. I mixed two group. I thought this is the third time we go through it. Yes, why not? All right. Let's start from the beginning. We have a cylinder. What does it mean, cylinder? Its moments of inertia is 1 over 2 mr square. Of course, it has a mass, it has a radius, it's a surface with friction, therefore there must be friction. What are the equations uh, we can use? There are equations for translation and rotation. For translation, which is technically the net force equal m times a. The net force here, of course, this is the x-axis, so on your right, this is the positive direction. Therefore, the net force is the F with the positive sign minus t. So the acceleration of the body can be calculated by this equation. But you remember the static friction is, we don't know at the very beginning, we didn't know it at the incline example either. So we can't go through with this equation since we don't know t and we don't know a. So one equation, two unknown is not we can solve. But there is rotation. The rotational form of Newton's second law. So this is like F equal m times a. What we should calculate at torque, sum of the net torque equal instead of mass, we can write moments of inertia, and instead of acceleration, we can write angular acceleration. Just copy it here. Alright, and now here comes the hardest part. Let's assume this is a pure rolling. What does it mean? Pure rolling means, wait a bit, I had somewhere. Pure rolling means that the velocity and the angular velocity and acceleration and angular acceleration is connected by the r. That means for pure rolling, the acceleration has to be r times angular acceleration. What does it mean? If you ride a bicycle, your acceleration and the angular acceleration of the wheel is connected by the radius of the wheel. So when when you accelerate yourself, the angular acceleration of the wheel will be a over r. So these are connected. So you can't imagine that, for example, you are accelerated, so your speed will be larger and larger, and the angular acceleration of the wheel is zero. So it rotates like a constant rotation. So no way. So they have to be connected. And with that translation, so the translation form of Newton's second law, or rotation form of Newton's second law, and the assumption of pure rolling, that gives you 1, 2, 3 equation, and the 3 unknown is t, a, alpha. So we can solve it. The only thing we have to go back is it true that it's a pure rotation or not? We can check it. Pure rotation is static friction. You can imagine when you ride a bicycle and you go to icy road, you rotate your bicycle, I mean you rotate your wheel, it will be faster and faster, but you can't be accelerated because it's an icy road, and the the wheel is accelerated, but the wheel will be angular accelerated, uh, rotates faster and faster, but you won't. Or even imagine that you start to ride the bicycle on icy road. You start to rotate your wheels, but you don't move anywhere. In this case, on icy road, the acceleration and angular acceleration is not connected because it's not a static friction, it's a kinetic friction. So pure rotation means static friction, non-pure rotation kinetic friction. So we by validating the pure rotation, we have to validate that this force is a static force. Let's connect the equation. F minus t equal m times a. The only force that can rotate this body is the friction. And this is true. So the mu between the wheel and the road is pretty large because because it can guarantee that this is a static friction. So since this force goes through the axis of the rotation, the sum of the torque will be only the t time r. So this is force, this is level arm. Why r is the level arm? Because the distance between force and axis of the rotation is exactly the r. So the net torque equal moment of inertia, which is 1 over 2 mr square. That's the moment of inertia times alpha. And once again, if we assume pure rotation, we can use this equation. How can we solve it? Let's combine these two. T times R equal 1 over 2m, and just write R times R instead of R square, because in this case you can see this part will be acceleration. We have R on the both side, so the T will be 1 over 2 ma. We still can't solve it because we don't know the T, we don't know the A, but with that information we can go back to the translational form of Newton equation and say, oh, F minus, and let's write 1 over 2 ma instead of T, means F equal 3 over 2 ma. Since F is 100, oh, I haven't had F, let's say it's 100 Newton, M, let's have it 20 kilogram, a bit heavier, radius can be 0.5, means 100 equal 1 over 2 times 20, oops, sorry, this is 3 over 2 20 times A, that will be, I think, 3.3. Yes, it's 3.3. A is 3.3. That's nice. From the three unknown, we solved one. This is, of course, meter per square. Let's go back here. 3.3 equal 0.5 times alpha. Alpha equal 6.6. It is 1 over s square. And let's go here with this information. T equal 1 over 220 times 3.3, and that will be 33.3 Newton again. How can we check it? Here comes the most important part, because we used this equation based on an assumption. We have to validate this assumption. Is it true that 33.3 Newton smaller equal than the 0. Oops, let's say 0.6, 0.6 times the mass, which is 200, which is 120 Newton? Yes. If yes, since we can use this equation, the results we have here is valid. Is it better now? By the way, on the next lecture we can also go through it. So this is three uh, equation, three unknown plus one condition. You have to divide it at the end. So if you can solve it, you can be proud of you. Oh, I'm very happy. All right. So on the next lecture, we go through the questions that will be fast enough, and we also solve it again. And by the way, this YouTube channel is wonderful. So you can recheck it even 10 times. So many people typing something. It will be in Moodle. I mean, uh, please come to the next seminar. So today I will learn how to create a test, and I think we can we can write we can try it. Let's try it on the lecture. So next Wednesday. I'm not that expert with that, so I try to create a pretty simple, just show up the example and you can solve it, and in a given field you can write the result. Uh, Hassan, I don't know. So if you ask your classmate whether you can help you, but if you look at this YouTube video several times, I think you can feel the steps. Right now, this is simple elementary school math. So multiplying, dividing, smaller equal, and so on. So I think this part, the math of this part, is even easier than the math of the first test. So I think you no need to worry about this test. I see the first test. Oh yes. I mean, ask your classmates and let's talk about it next Wednesday. And also check the first YouTube videos. Oh no, there's no YouTube videos because it was offline. All right, uh, let's. I will find out something. I mean, let's talk about it next Wednesday. So please come next Wednesday and we can find out something. So, for example, I can create a very easy test without any integration for you for the test one. All right. Uh, See you next Wednesday. No, my next class starts in 5 minutes. So uh, see you next Wednesday and then look at the questions, look at the YouTube videos. Let's prepare yourself. Bye.